Equations. How do you solve the same equation two different ways? That's what we're going to look at with this little mini lesson up here. The first problem that we see in front of us, we know how to solve that without any problems. We know how to go through and say, you know what, my variable's on the left side, I'm going to add 12 to both sides, which we are doing. Therefore, negative 12 plus 12 is 4x, and then 8 plus 12 is 20. Divide both sides by 4, because we're going to get x to equal 5. We know that, no problem. What if, though, I wanted to solve this differently? So that's way one that you should have down in your notes. That's the first way to solve that equation, is to add to both sides or subtract to both sides and then get your variable alone, etc. Find 1x. Here's way two, though. Way two actually takes a look at both sides of the equation. So what happens if I wanted to divide both sides first? Well, here's what I have to look at. I have to look at the entire equation up here. I have to look at the 4, the coefficient in front of my variable, the negative 12, and the positive 8. Do they share a common factor? In this case, they do. I know that 4, negative 12, and positive 8 all divide by 4. So what I could do, and remember again, that our answer was equal to 5 the first time we solved it, correct? I could here divide everything by 4. Now the trick is, again, you have to divide or multiply the entire side. So in this case, I could divide the 4x by 4, which I know gives me 1x. I could divide the negative 12 by 4, which I know gives me a negative 3. And then that's equal to 8 divided by 4, which is 2. And last step here, this time now I have 1x first, so then I can go through and add 3 to both sides, and therefore get x is equal to 5, as we did the first time we solved this equation. So that's with the standard two-step problem, and solving it two different ways. Next, we're going to look at how do you solve more of a three-step problem in only 2 to 3 steps. So it is still, you could still get a 3-step problem, but we're going to solve it a little bit quicker. So here's that 3-step problem we were looking at. And the first way I could solve this is how we've done it before, taking the 5 and distributing it to both the 5v, the v and the negative 1. So then I have 5v minus 5 is equal to 10. So that was step 1, distribute, as we've always done. Step 2 then goes through and adds 5 to both sides, and then therefore we get a 5v is equal to 15. This is, again, review, and divide by 5 to both sides to get that 1v up here, and 1v is equal to 3. Pretty simple how we went through and did all that work. So that is what we already know how to do. Distribute first, and then go through and solve a two-step equation. But I'm going to move all this stuff over, because now what I'm going to do is I'm going to do this a little bit faster. I'm going to do this a different way, so get rid of all that distributed stuff. Now what I look for is that second way to solve this equation. And remember, v is equal to 3. Here's what I notice. Kind of like the first example that we had, where we noticed that every single term up there divided by 4, I noticed that the terms on the outside of my parentheses here, the 5 and the 10, on both sides of the equation have a common factor. They both divide by 5. So here's what I'm going to look to do. I'm going to look to divide both sides by 5 and see if that gets me the same result. Now, the nice thing about this one is I have a parenthesis up here which shields everything that's going to happen on the outside. And what do I mean by that? If I went through and decided to multiply both sides by 2, which, you know what, I could do that. Is it going to make it any faster for me? No, but I could do that. Out here, because I don't know what v is right now, I'm not going to take 2 and multiply it by the v and the negative 1. That's actually incorrect, because we know we're going to be distributing this 5. Okay? So what I actually would do would then be just multiply 2 times 5 out here, because multiplication is commutative, which 2 times 5 is 10, and then that would give me, I don't want that 5v right there. That should just be v minus 1, and that's equal to 20. Now again, is that making it faster for me? No. But I'm just showing you out here, the parentheses are actually going to be protected by every operation that I do. So now what do? I notice that the 5 and the 10, both on the outside of those parentheses, and both have a common factor of 5. So what do? I go through and I divide both sides by 5. And here's the nice thing about it. We've seen this before when we actually had those equations that were over a number and we actually cross-reduced, and remember we actually made the parentheses around that. So we're going to do something very similar up here. The only difference is now we're not cross-reducing, now we're just reducing the 5's. So I know 5 divided by 5 is 1, and 1 times v minus 1 over 1, guess what? The v minus 1 is just going to drop down. So therefore we have a v minus 1 is equal to 10 over 5 we know is 2. Now, I know it took a while explaining that, but I want you to see how many steps am I going to solve this equation. Over here, I did it in distribute first, add 5 to both sides, and then divide by 5 to get 3. Here, just by knowing something little quick, a little small detail, I go through divide by 5, then add 1 to both sides to get v alone, and v equals 3. I actually did that in not 3 steps, I did it in 2 steps. So here we go, last example. Both problems, I'm going to do them 2 different ways. So, the first way is the one that we already know, distributed property. So first I'm going to go through here, distribute this 3 to both sides, or excuse me, to the 4m and the positive 3. I know I'm just going to drop down to 21, and then 3 times 4m is 12m, and then 3 times 3 is a positive 9. In that case over here, subtract 9 from both sides because I want to get my variable alone, and in this case I am getting that alone. So then 9 minus 9 is obviously 0, so 12m is equal to 21 minus 9, which is 12. Divide by 12 to both sides. So therefore I get 1 is equal to m. Now the other one. Again, little trick that I notice. Everything on the outside here, I see 3. The only other term outside a parenthesis is this 21. So I'm going to divide both sides by their greatest common factor, which is 3. I'm going to do that to both sides then. Get a different color. And now when I go through and divide both sides by 3, 21 divided by 3 is a positive 7. 3 divided by 3 is just 1, so that 4m plus 3 is just going to drop on in. And now solve for m by subtracting by 3. And therefore I get 7 minus 3, which is 4. It's equal to 4m. Divide both sides by 4. So therefore, again, 1 is equal to m. So you see, just if we do see that little tweak in some of these equations, if we do see that pattern, 3 divided by 3 and 21 divided by 3, kind of makes it a little bit easier. It takes out the distributive property where we could get a little mixed up with our operations. I know a lot of times we get mixed up with the signs in here, if they're negative, positive, etc. So just by observing, we can actually make these equations a little bit easier. Okay. So to finish up, your code tonight for the form that you are going to complete, it is the word multiple, as in there are multiple ways to solve these equations. So do the best you can, ladies and gentlemen, and good luck.